Vinny? So when it comes to projects that actually make me money, majority of those projects end up actually being on the video side, primarily like an image, a little bit of audio, and then from there, chat is kind of a novelty for people, it seems to me. And I never get contacted, like almost never, with regards towards data analytics and like AI for outside of generative AI. But it's the biggest use case that uh, businesses, etc. They're the ones that want to utilize it, and they want, and it's always video and images. So a big question that comes up within that is like, can I actually do those things, and am I actually familiar with them? Because I generally talk about like transformers and chat models and things like that. But so yes, I'm very familiar with these architectures as well. And so this video is going to be kind of just a crash course. It's so the middle of 2025. It's the 3rd of June as 2025 as of the making of this video. And purpose of this is to give you an idea of where all of this currently stands as far as technology, what you can do with it with regards towards video generation, image generation, video editing, etc. with AI. So let's dive into it. On the model side, the big kind of breakthrough, and what I've been telling people to anyone that I've been talking to this around this subject with, is to wait, right? That we're in a period right now where the models that exist today and the top models that exist today aren't going to be the top models tomorrow, because you can see exactly where it's going, which is like essentially a merging of all of these technologies together, right? An LLM model is just an LLM model. It's a chat model, but when you incorporate vision on top of that, it becomes a VLM model. When you incorporate reasoning into that, it becomes a reasoning model. And then within that, we're starting to fuse all of these different elements and dynamics together, right? VO3 is the first models where you can actually utilize audio and video and creation and one. And then so it's just, I mean, that's the closed loop, right? And then also too, within all of these, the backbone with all of these current and modern models is transformers, right? It's usually diffusion transformers. And then so within that, it also gives you the capabilities of having an encoder for text and things like that. And I'll dive deeper into the model dynamics here in a bit. But so the two big things to keep in mind right now, like if you're looking at these things and you want to know like real world use cases, real world models, what are the ones that I should be looking at? As far as on the open source side, there's the commercial side, right? And then I don't know, it's funny to me because OpenAI said that they should have, or said that they were going to release an open source model in March, and it's now June, and they haven't released anything. And then these models are from Alibaba and ByteDance. And then to me, these are the companies, and they're showcasing they're what OpenAI should have been. But here we are, right? But so this first model is WAN 2.1. It's an open and advanced large scale video generative model. And then so it's just, straightforward as to what this model does on a base level. It's text to video, right? And then you also have image to video. But the cool thing about WAN 2.1, and we can take a look here at this one, WAN open and advanced large scale video generative models, and it's put out by Alibaba Group. And then so this is the paper that they put out, and then it's like the archive paper. It's a 60-page paper. And then they just essentially go into the infrastructure, the training, everything involved within it, the data set. They open source it all, right? So that's the great thing about this. But so what you can see within these models is, so you get your input video, and then it's an encoder and a decoder. They're shrunken down to two-dimensional space, and then you have your output video, and then these are all done via variational autoencoders. So VAEs are very important within this. This is like the VAE, and then so model design is pretty straightforward, right? So it's all no matter what, and I talk about this a lot on my channel, it's all like the models always crave, they want low dimensional latent space, right? So like even if you're giving them these high dimensional images, like with lots of data points, etc., they always want it to be in two-dimensional space. So whenever you're giving it to the model, that's exactly what you're doing, is you're encoding it into two-dimensional space, right? So that's what the encoder and the decoder does. Is the encoder takes this image of a panda and then it makes it like compress like smaller and smaller, right? And then the decoder is able to take that small, like that like compressed image, and then okay, that's a panda, and then that's kind of how it works within that as well. And then you have within like all of these the transformer block, right? So then that's like a well, the transformer block within that is exactly how you get the text to speech and like all of the like the textual understanding within the model overall. A few things to highlight within this, and I do want to point out is that so these models, like they very specifically do go through a temporal training, and so I talked about this yesterday on my channel, right? And it's just I highlighted because it's super intriguing to me. So this is like it's a diffusion transformer model, right? And so the diffusion portion of this model, like the paper that I went over yesterday, I talked about essentially problems within transformers architecture, and then very specifically within that architecture as a whole, right? But within the diffusion architecture, there's diffusion architecture is temporal based, like it should be. It should be able to simulate the temporal time based inputs, right? And it's given time based inputs, like, and it's given like it's video, right? So like it's trained on time-based video and then time-based dynamics, and the model is able to pick out and understand physics within this, right? That's an early part of these models, was like physics understanding, and then so a large part of the training within this is actually physics understanding as well. But as stated yesterday, with all of that physics understanding, the one weird thing is that they can't understand time. 0% across the board. All of this training, none of these models understand time. I just think that that's an interesting concept overall. But the second thing is like more real world and more grounded within these things. Going back to that, is that this model design does include what you can see here, like so things like a clip and that VAE, that visual audio encoder, and then so what that allows to do is for video personalization, right? And that's what that all boils down to, is like, so this model does have built-in editing capabilities as well. So like not just generative capabilities, but video editing. And then so that's where we're going. And again, that fusing these models more and more, right? To me, VO3 is the big gold standard right now with regards towards all of this fusion together. What's missing within WAN 2.1 compared to VO3 is flat out there's no audio, right? Like you can get like, so WAN 2.1 has the ability, and it does text to image generation. So like or you can do text generation within your video generation, but it can't do audio. And it's just not like WAN 3.1 or WAN 3.0, I'm assuming will, but WAN 2.1 cannot. And then so the next thing to talk about within that is that actual that whole entire fusion process, right? Like the essentially you're fusing different modalities together: audio, video, image, text, etc. And then also reasoning, like physics understanding, etc. Right? And then so how all of that works out. This is called Bagel, and then this is released by ByteDance. And then if we go to here, sorry, this is the one for Bagel. Which is it's based off of this VAEs, all-in-one video creation and editing. And then so what we see here within the this and the dynamics and the specifics of this, actually I can go here to this. And this one is super new. So May 23rd, 2025. But so emerging properties in a unified multimodal pre-training. And then so this is um, I thought it would take us longer, essentially, to catch up with. So VO3 is the standard right now, right? And then, but so if you want to like be at the absolute standard, like I want that VO3 technology, and I don't want to like utilize Google for whatever reason. I want it to be like open source. I want to own it. I want to own the technology, etc. This is where we're at. So this emerging properties and unified multimodal pre-training is like exactly where we're at. Within this, like all of this, so all of the image editing, the image generation, all of the like the editing technology when it comes to all of this, it's all based off of like this bagel, right? And then so bagel is just all of again, it's two transformer models in this particular instance. So, and then it's just all like transformer and diffusion based. And then so in this instance is an external diffuser, which is interesting, right? So then it's, you have your essentially like LLM model, and then the external diffuser attached to that. But then you also have an integrated transformer, which is like the bridge between them. So that's the bridge layer. And then so it's kind of just an interesting fusion dynamic, right? And then so all of this is about fusing different modalities, and then about like again, the larger goal within this is to like have it so that I think by the end of this year you'll have a LLM model that you can just prompt, be able to do any sort of editing that you want. You can have it generate the video, edit the video, put any sort of like LoRa that you would want on top of it from there, etc. But at the moment, it's still kind of disparate as far as the models. You need like two different models at least. But so then with WAN 2.1, what's like the major benefit with this model overall, right? Why would you want to use like this model? And then why wouldn't you use like this, the bagel technology by itself? Major reason for utilizing this model very specifically. If we go to the model card here, we can see it's got like 35. So this was this model here that we're looking at. If I can, actually, I need to go from spaces to the actual model. So let me pull it up here. There we go. So this was updated 16 days ago, and you can see 37,000 downloads. And like I checked this like an hour ago, it was like 35,000 downloads. So it's like, and then there's also, so there's the 14 billion parameter model and the 1.3B model. The reason why you want either one of these is that these models are very specifically made to support consumer grade GPUs. So the 1.3B model requires only 8.19 gigabytes of VRAM, making it compatible with almost all consumer grade GPUs. It can generate a 5-second 480p video on an RTX 4090 in about 4 minutes. And that's without any sort of optimization techniques like quantization. Its performance is even comparable to some closed source models. And then so there you go, like on your home computer, video generation is now 100% possible within the status quo. And then so you can do and utilize the WAN 2.1 models, and then that's very specifically the WAN 2.1 1.3B model, which is going to be significantly not as good as the 14 billion parameter model as far as outputs. Like you'll notice some performance differences between the two for sure, but 14 billion parameters, it's like that model you'll need a lot more like non-consumer grade GPU basically. Like when they're saying the support for consumer grade GPU, they're very specifically talking about the 1.3B model overall. But so I think that so for my expectation is that these models will be and reign supreme for the next few months. So like if you have projects like you need to like get a head start and you want to get a head start on these things and you want to start working on them, you can invest in these, right? Like the good thing about this is that like these models are free, right? So there's like no investment in regards towards the software. It's the investment is into your team, understanding how to build, play with these things overall. And then when my expectation is that like, let's say 2 to 3 months from now, at like maybe 6 months at tops, you're going to want to switch to like what will be like a full LLM model, like we'll call it like a VLM with reasoning or whatever they'll be called at that time, right? And then that will have all of this within it, and you'll just essentially prompt it and you'll change it from there. But so from there, it's just a matter of like swapping out the model on your back end. Like it won't be a lot of like change for your team overall. From like it'll be easier for your team like once you do that. And then if you're not paying for the software, it's just a matter of paying for the installation or understanding how to do the installation, because it's just a matter of like swapping out the software at that point. And at the point where you have the software to handle this, you're going to have this, or the hardware to handle this, you're going to have the hardware to handle any other model that you'd be dealing with there. So it's just understanding your own systems and building those out as a team, right? And then so that's, I guess, the last thing that I'll state within this that like people don't understand. I try to portray that as much as I can, that there's a difference when it comes to investing in AI as opposed to investing in traditional IT, specifically for businesses overall, right? Within that, being that like within traditional IT, the majority of your expenses within the software itself, within the it's expensive to switch. There's a lot of elements that are frankly built into the model, right? Whereas with and it's so there's expectations that have now been built up along with that. Whereas AI operates the exact opposite. The software is free, and then it's the best thing that you can do is build up internal knowledge within these things. And then so, and like, whereas with IT, it's software. The software is changing, and it's not really like intuitive for you to have. If you're building up in-house knowledge on very specific software, you're building up in-house knowledge for a different company, for another company, right? Whereas with AI, at this point, it's the exact opposite. You're building up internal knowledge that becomes a moat, an advantage for your company versus any other company when it comes to these things overall and understanding how it works overall. So it's like inverse of the traditional IT model within these things, and I think it's like important to understand that. So I'll leave a link to these research papers, and then again, the model is a WAN 2.1. The two big things to check out on the model side are WAN 2.1, and then Bagel is the back-end technology behind a lot of the like the imaging and everything that you would want with regards towards the fusion, and then bringing and melding all of this together. And then so if you like this type of content, please like and subscribe. Thank you very much.